What if I told you the ocean is speaking to us? Not with words, but with whispers. Soft signals from the deep, bubbles breaking, wind stirring, and currents sighing. And what if I told you we're just starting to listen? My name is Louise Delaigue. I'm an ocean and climate scientist, and I'm also a passionate scuba diver. From the kelp forest in South Africa to the icy waters of Iceland, and especially here at home in the Mediterranean Sea. And I've seen something again and again. The ocean is changing, not from scientific papers, not from climate reports, but right here in front of my eyes, underwater. Warmer water, fewer fish, coral bleaching, kelp thinning. The ecosystems we once knew are changing, rearranging, and slowly fading. But the truth is, we don't know everything. So I turned to science. And the other truth is, science doesn't know everything. There are still big blind spots, huge ones. And one of them is, we still don't know what the wind is doing across much of the ocean. And that matters a lot more than most people realize. The wind is actually crucial in shaping the ocean. It stirs the surface, it brings up nutrients, and it helps the ocean breathe. And by breathe, I mean this. The ocean absorbs 25% of our CO2 emissions every year. And that's the CO2 from our cars, that's the CO2 from our factories, and that's the CO2 from our flights. It's basically the invisible exhaust of modern life. And much of that CO2 actually doesn't stay in the atmosphere. It's taken up by the ocean. So in a way, the ocean is kind of buffering us from the full force of climate change. But this comes at a cost because when CO2 dissolves into seawater, it makes the ocean more acidic. And this affects coral reefs, this affects plankton, and this affects the tiny shells at the very base of the marine food web. So understanding this cycle, how much carbon has been taken up by the ocean, is very important. And that's where the wind comes in. Because wind creates waves, and waves create bubbles. And these bubbles actually help draw CO2 down from the atmosphere into the ocean. And this process is really important, and it's especially important in stormy regions like the Southern Ocean. In fact, the Southern Ocean is the biggest carbon sink on the planet. It takes up more CO2 than any other ocean region. And roughly 40% of all oceanic carbon uptake happens in the Southern Ocean. And yet, it's also one of the least observed parts of the Earth because it's remote, it's stormy, satellites struggle, ships avoid it. If we're being honest, scientists avoid it a little bit too. So the place doing the most to help us is actually the place that we understand the least. And the thing is, those future climate scenarios that we all hear about that are built by the IPCC, they all very much depend on how much carbon will be absorbed by the ocean in the coming decades. Which means if we don't understand the wind, we can't model how the ocean breathes. And so we can't know for sure how these future scenarios will play out in the future. And that's the problem, and that's exactly what we're trying to fix. So we built a listener, a robot floating silently through the deep. It's called the BGC Argo Float, which is short for Biogeochemical Argo Float, which sounds technical, but please stay with me because this is very exciting. It's gray, it's long, it's about the size of a person. It's a bit awkward looking, like some sort of submarine designed by a minimalist, but it's really great and very useful. It drifts freely through the ocean using ocean currents at depth of about 1,000, sometimes 6,000 meters. And when it comes back up to the surface, it records data. And this data includes anything like oxygen, pH, chlorophyll, nutrients, even how much sunlight comes down from the surface. So in other words, it doesn't just measure the ocean, it measures how alive it is. And for the first time, we gave it ears, a tiny underwater microphone. So in between profiles, when it's just doing nothing, drifting along ocean currents, it listens, but not to dolphins or whales or anything glamorous, but to the subtle hiss of wind reaching down from the surface. And this year, for the very first time, we tested this in real life, real ocean conditions. Funny enough, just across the road from here, in the Mediterranean Sea. We deployed one of these floats, and for weeks it drifted and it listened. catching the breath of the wind from hundreds of meters below. Now, these acoustic methods to get wind from underwater noise are not new. Others have tested similar systems, even on floats like these. But what we've done here is we've actually taken it one step further, because we're not only getting wind, we're actually connecting it to the other biogeochemical sensors that are on the same float. So in other words, we're connecting the wind directly to how the ocean breathes. And that's a major step, especially since what we want to build is a network of fully autonomous tools so we can monitor the ocean carbon sink. And it worked. The float could hear the wind from hundreds of meters below. And when we compared those results to a nearby weather buoy at the surface, which also had real wind speed data, they matched almost perfectly. Another thing, we noticed that the float actually can pick up subtle, stronger bursts of winds that satellites had missed. And these moments are really important for carbon exchange. All this from a single drifting robot. Nothing fancy, no surface antenna, no satellite link, just sound. And this proves that this is possible, not just in theory, but in the real world, in the real ocean. Now, what this also means is we can now actually listen to the winds in the most remote places of the ocean, even in stormy conditions, even when satellites can't see, even when no ships are nearby. And what really gives me hope is that we don't need to build a massive infrastructure to do this. We don't need a billion-dollar mission. These floats, they already exist. They're small, they're cost-effective, and now they can listen. So if we can add this data to our climate models, we can improve our predictions, because even today, even in 2025, we still don't know how the ocean carbon sink will respond to future change. So if we can listen, really listen, we might be able to paint a better picture of what lies ahead tomorrow. Now, this isn't just about research, and this isn't just about robots, this is about all of us, because the choices that we make on land, things like what we buy or how we move around or how we vote, those choices, they ripple into the sea. Every ton of CO2 we reduce gives the ocean a little bit less to carry. Now, I am fully aware that not all of you tomorrow will go out in the Mediterranean Sea and deploy floats. Fully aware. But you can still amplify the science. You can share it. You can talk about it. You can remind people that the ocean actually isn't just seawater. It's a living, breathing part of our climate system. It's trying to speak up, and our job is just to listen. Thank you.